Welcome everyone. Hope you can hear me clearly. My name is Violet Sia from Enterprise DB APJ Marketing, and I will be your host today for our webinar on making your PostgreSQL database highly available. I'm joined today by Alok Minstra, Senior Sales Engineer at EDB, who is our speaker today. Before we get started, I just want to go through a few housekeeping items. Please know that this presentation is being recorded, but we will be sharing the recording along with the slides after the broadcast. All your lines are also muted, but if you have a question, please feel free to submit it in the Q&A box, which you can find at the bottom of your screen. We hope that the session will run smoothly because Alok and I are working from home. So if there are any connectivity issues, we ask for your patience and understanding. This session is scheduled for 1 hour, and we expect the presentation to last approximately 15 minutes with some time for Q&A. If we do not have time to answer everyone's questions, we will follow up via email with you directly after the session. So now, without further ado, let me pass the call over to Alok. Over to you, Alok.
Yeah, sure. Thank you. Thank you so much, Violet. Okay, so hello, everyone. Good morning, good afternoon, and good evening, as per where you are. My name is Alok Mishra. I work as Senior Sales Engineer here in Enterprise DB and part of the Australia New Zealand EDB sales team. And today's topic is making PostgreSQL highly available. Okay, so let's start with our agenda today. So these are the points I will be covering during today's session. So first, I'll talk about who is EDB, but don't worry. I'll not take much of your time, not more than 2 or 3 minutes on the slides I have about Enterprise DB. And then I'll come to our today's topic, and I'll talk about the high availability basics and the terminology. Then we will see how high availability works. And then we'll see the built-in PostgreSQL options for high availability and how you can, which option is better for you. And after that, we'll see the multi-node architecture for high availability, which you may want to consider based on the built-in options of replications within the Postgres. And then at the end, we will also see how EDB tools can help you for high availability management and monitoring. Okay, so these are the points I will be covering. Okay, then let's start from a few words about Enterprise DB. So Enterprise DB is a database platform company for digital business. We provide software and services based on the open source database named PostgreSQL. Okay, so basically we are PostgreSQL Solutions and the tools company headquartered in Massachusetts, USA, with 16 global offices. EDB was founded in 2004, and since then, EDB has been one of the leading supporter and developers of PostgreSQL. We have 500 plus employees and 5,000 plus customers across the globe. One very important thing to notice here is that Enterprise DB is closely involved with and committed to the PostgreSQL community, and of course, contributing since 2006. Even some of the EDB team members have been involved with the community project since its inception in 1996, and they are still playing a key role in making the Postgres better for the world. Okay, another important point I have to discuss here is the Gartner's recognition. So because of our strength and capabilities, which EDB has developed in a decade, Gartner has positioned Enterprise DB in the Magic Quadrant for operational database management systems among the other elite database vendor for consecutive 7 years. So I'll repeat, it's for consecutive 7 years, EDB has been part of the Gartner's Magic Quadrant. now Enterprise DB is the only open source based relational database vendor in the Gartner's Magic Quadrant. Okay. Okay, so this is the last slides I have for Enterprise DB, and here I have something interesting news to share with you, though you might be aware about it. So EDB has acquired Second Quadrant recently in September 2020, and with this acquisition, now Enterprise DB has become the largest dedicated PostgreSQL company. Okay, so what does this mean to us? I mean, of course, now EDB is the largest dedicated PostgreSQL company after this acquisition. But it also means that now Enterprise DB has more customers than any dedicated PostgreSQL company, right? It also means that now we have more PostgreSQL expert, right? More community contributors, more committers. And it also means that now more innovations, right? And of course, our increased capabilities to address the new opportunities in various new and emerging areas. All right, so this is what we are, and this is where we are, positioned. Now, let's start with our today's topic, which is the high availability basics and terminology. So in the coming slides, we'll see what exactly high availability means, okay? And then we will see the commonly used terminology in context of high availability, so that when I use these terms going forward, during the presentation, we all are on the same page. All right. So high availability. I have taken this definition directly from the Wikipedia. So Wikipedia says that high availability is a characteristic of a system which aims to ensure an agreed level of operational performance, usually uptime, for a higher than a normal period. Okay, so in simple terms, high availability is something that can help keep your systems, whether it is application, whether it is the database, whether it is the infrastructure component. So to keep your system available all the time to achieve the committed level, the SLA, the service level. We'll talking about what the SLA mean. And but of course, it's all about achieving the committed service level by keeping all your infrastructure components available 24/7. All right. And you can achieve this high availability by maintaining these three principle of high availability, which again I have taken from the Wikipedia. So the first principle says the eliminating single point of failure, right? The second one is reliable crossover, and the third one is detection of failure. And these key points, are going to be the center of our today's discussion. We will talk about each principle in detail in the coming slide, and we'll see how we can follow them to make the PostgreSQL highly available using the native Postgres features, the inbuilt features, also by taking help of Enterprise DB tool. Okay, so before we dive into the key principle of high availability that we just discussed, right, let's quickly see a few of the most commonly used terminology in context of high availability. So the first one is SLA, right? Then what is an SLA? Basically, the SLA is a definition of the service level you plan to provide to your customer, right? So SLA for them is to better understand the level of stability you plan for a service that they have bought or are planning to buy. So, I mean, when you say SLA, it says that, okay, this is the service level, the agreed service level, or the stability of the service which you are providing to your customer. All right, so there are numerous methods you can leverage to prepare a SLA, but the typical one is availability of the service, right? And availability is typically measured in nines. So let's look into this table, what exactly a given amount of 9 guarantees, right? Again, this has been taken from the Wikipedia. So we look at the table, and let's say if we say, okay, our SLA is 49 or 99.99%, then it means that we are saying that, okay, a customer, customer can have 52.60 minutes of downtime per year, right? Or 4.38 minutes of downtime per month, or similarly 1.01 minutes of downtime per week, right? If you say that, okay, our SLA is 99.99%, which is 59, then it means you are committing to your customers that there will be only 5.26 minutes of downtime per year, right? 26.30 seconds of downtime per month, and similarly 6.05 seconds of downtime per week. So this is how you calculate your SLA and you commit this SLA to your customer. I mean, there are factors you need to consider while calculating the availability. I'll not go into detail on these points, but I'm sure that you may have heard SLAs as as 4.9 or the 5.9. Okay. Okay, so apart from this SLA and then availability, right, there are a couple of other terms like RPO, RTO, MTTR, and GRO. Let's quickly look at these terms so that when I use these terms going forward, we understand, what we are talking about. All right. So RPO and RTO, okay. Uh, so RPO and RTO are the two most important terms used with the high availability. Uh, let's look at the RPO first. So in simple term, RPO means the amount of data you are ready to lose in case of any major incident, right? Or the amount of data loss you are able to tolerate. So for example, if you say, okay, I'm okay to lose an hour of data, it means that in case of crash, you need to forget everything you did in last 1 hour, all right? Uh, Now, what is RTO then? So in simple word again, RTO means the time, right? The time required to recover the database after the crash, okay? And it primarily depends on two things. One is, of course, the time it takes to load the initial backups. And of course, the second point is the time it takes to, replay the WAL files, right? Either the archived WAL files, also the WAL files which are not yet archived, right? But they are necessary to make your backup consistent, or which are necessary to take you to the points, right, where you want to be. Okay, so RPO, RTO, then we have another term called GRO, which is geographic redundancy objective, right? So again, it simply means that if my data center becomes unavailable, how long will it take for the service to become available again? So this is what GRO is. And there is one more term, in terms of HA, which is MTTR, right? So MTTR means, again, on an average, how long these RTO will be. So these are a few jargons, I'll say, or the few terminology which people frequently use when they talk about high availability, when they set up high availability in their environment. All right. So now, after discussing the definition of high availability, the key principle, right, and these basic terminology, let's now dive deeper into the high availability principles to have the highly available database environment. So we will start with the first principle, okay, which we just saw in the earlier slide. So what is that first principle? The first principle is eliminate single point of failure. So this is a key requirement to achieve high availability of any component, including the database. So how will you eliminate single point of failure? Of course, adding redundancy, right? So that the failure of any one part of the system does not lead to the collapse of the entire system, right? So this is how you can eliminate the single point of failure. Now let's see what all options you have in Postgres, which are available, inbuilt, which you can use to eliminate the single point of failure. Okay, so in PostgreSQL, we have three ways to achieve this. The first one is the WAL shipping based replication, right? So in this first approach, we could build a system in which standby can receive the wall files from the primary server in the form of archived wall files. And so primary is just archiving the wall files using the command mentioned in the archive underscore command parameter in the PostgreSQL.conf file of primary server, right? And the standby will be receiving those walls using the restore command from the archive location. The restore command, which you specify in the recovery.conf file, if you are on PostgreSQL version 11, or if you are on 12, then of course, the restore command which you specify on the main PostgreSQL.conf file. The second approach we have to eliminate the single point of failure is streaming replication, which is quite widely used after 9.0. So in streaming replication, we could build a system in which standby will stream the walls from the primary using the lipugi protocol instead of receiving the data from the archive locations, right? And the second and the third option we have is now the logical replication. So what is that logical replication? In this logical replication, we do not create a binary copy of this replication. Rather, it is a streaming of the logical data modification from the wall file. So how does it work? So basically in this method, primary uses one of the logical decoding plugin to decode the wall files and apply the generated SQL on the standby. But please bear in mind that from the performance point of view, this logical standby is slower than the physical standby. Okay. Okay. Now there is another term called hot standby, right? So when you use, if you're aware about the streaming replication or the replication methodology, the standby is a term which is frequently used. So what is that hot standby? So there is so the hot standby, it simply means it's a term used to describe the ability to connect to the standby server and run the read-only queries on the hot standby server when your hot standby is either in archive recovery mode or the standby mode. So basically, this is identical to the primary system, right? And so data is still mirrored in real time. It can be mirrored using the archiving method, the wall shipping method, or it can be mirrored using the streaming method, where you will have one wall sender on the primary and one wall receiver on the secondary. All right. And of course, you can run read-only queries on the hot standby. And in case of failure, your hot standby can be replaced, can replace the primary. So hot standby can become the primary. And of course, then you can rebuild your older primary to make it, hot standby again. Okay. So this is how it looks like, right? If you are creating a hot standby via the wall shipping methods, you can see that here I have a primary server, then I have standby servers here, right? And standby servers are fetching the walls or receiving the walls from the archival locations, right? There are a couple of parameters which you need to specify on the primary side. One of the important one is, of course, the wall label in the archive command, right? And the second one is, and then there are a couple of parameters which you need to specify with on the secondary side, right? And the hot standby one is the important one, and the recovery target timeline. These are a few important parameters. Then we have second parameters. Then we have, the second option of configuring hot standby via the streaming replication. So this is how it looks like. Here also we have a couple of more parameters as compared to the previous one, right? But in this case, rather than the archived walls go from master to the standby, there is one wall sender process on the primary, there is one wall receiver process on the standby, and the standby streams the wall from the master directly. There is one important parameter in this context, and that is replication slot, right? So replication slot, you can use replication slot. So for example, if you think that in your environment there is, you think that the network is not quite stable, or you might face intermittent network issue, you can use this replication slot parameter. What it will do is it will store all the archived walls which are not yet applied on the standby, right? So until they are not applied, they will be with the primary. But this comes with another responsibility where a DBAs need to keep an eye on this replication slot and make sure that your standby is not down for a longer period of time. Otherwise, of course, these walls will take time on the master, and that may cause some error going forward. Okay, so hot standby, then hot standby via wall stripping, and hot standby via streaming replication. Now, so if you go to decide with the streaming replication, then streaming replication configured in the two mode. Okay, so the first one is the asynchronous streaming replication, and the second one is the synchronous streaming replication. So let's see what these replication modes are. So the asynchronous replication is, I'll say, a standard way to replicate the data in Postgres, and it offers a reliable and the easy way to distribute the data between primary server and the standby server, right? The main advantages of the synchronous replications are low overhead, simplicity, and robustness. But of course, there is then one drawback with this asynchronous streaming replication, right? So you need to bear in mind that if you are running the asynchronous replication, the data might hit the standby after a transaction has been committed on the primary server. All right. So there is usually a small replication delay, which can cause minor data loss in case of crash. So this is, I mean, you need to keep in mind, though it is robust, though it is quite simple in terms of configuration, but yes, it may cause a data loss in case of crash, right? But yeah, if you are not able to take the risk of losing even a single commit, then of course, synchronous replication, which is the second mode of configuring streaming replication, is something that you are looking for. So in PostgreSQL, you can replicate synchronously to as many standby as you want, to ensure that a commit is only valid once it has been confirmed by the desired number of standbys in the PostgreSQL server, right? So basically, in synchronous replication, uh, uh, it ensures the highest possible security of your transactions. And because, until the transaction is committed on primary as well as one or more standby, the the confirmation, the commit confirmation is not sent back to the client saying, okay, the data is committed and the master is ready, or the primary is ready for the next transactions, right? So of course, the data security is more in terms of streaming replication, synchronous streaming replication. There is one more concept regarding the synchronous replication that is called quorum commit. Okay, so so this quorum commit can be implemented using a parameter called a synchronous standby name. This is new, starting from Postgres 10.0, right? To read more about this parameter, you can go to our PostgreSQL document link given on the slide to understand how you can use synchronous standby name parameters, right, to make synchronous streaming replication more robust. All right. Okay. So now, when you understand the streaming replication and its mode, let's talk about two Postgres referenced architecture based on synchronous streaming replication as well as asynchronous streaming replication. So, so in a multi-node cluster, right, with the asynchronous replication, we will have a primary server with one or more typical hot standby server, right? And you can use the hot standby server for read-only workload. But because this is a sync application and you are running read-only queries on the standby, you need to keep in mind that the queries run by your application may not necessarily instantly visible on the standby server, right? So you need to make sure that your application is prepared to deal with delay. That once that all the transactions as they are available on the master side or on the primary side may not instantly be available on the standby side. Also, at the same point, if something goes wrong, right, and the failover happens, then of course you may lose some data, right? And it is because it is because of the replication lag that may cause you some transactions during the failover event. So this is what you need to keep in mind. But of course, you can use this multi-node architecture with asynchronous replication. If we talk about RTO, the recovery time objective in this architecture, so that is typically less than 60 seconds, and that is because the failover can happen very quickly. I mean, obviously, it requires proper tuning and appropriate monitoring, and we will look at how that is done in a moment. But yes, in this architecture, the RTO can be achieved, which is less than 60 seconds. In terms of point in time, in terms of the recovery point objective, we can say that typically it will just up to a few seconds. So, actually it depends on how busy your system is, uh, what the workload looks like, and how well your servers are keeping up with that workload. So depending on that, you can decide or you can reach to your RPO targets. The GRO, the geographic redundancy, is dependent on the node placement, though it is very, very quick if you have a multi-AZ deployment. And at the last, regarding the target availability or the service label, we can say that assuming nothing else fails in terms of hardware or in terms of environment or the network and so on, then of course you can achieve 4 nines of availability. Okay, so this is how it looks like. So you can see these green lines, they show the read write connections from to the master, right? The red line shows the read only connections, and the blue line shows that the data is being streamed asynchronously. So this is how you can use this multi-node architecture with streaming asynchronous streaming replication. Now, moving on to the second Postgres reference architecture with the synchronous streaming application, uh, because uh, because it's a synchronous replication, right? The transaction is committed on the primary, and of course, one or more standby before the confirmation is sent back to the client. But keep in mind that because of this extra handshaking due to this two-phase commit, the synchronous replication option is uh, is less write. I'll say less write performant as compared to the asynchronous one. So because here, uh, uh, the primary will have to wait for standby to get the acknowledgement from, so that they can commit to the client. Of course, it takes time, and hence it is less write performant as compared to the asynchronous one. But it also means that you do not lose committed transactions if the failover happens. All right. Regarding the RTO, RPO, and GRO, they all are largely the same as they are for the asynchronous replication. The only real difference here is that you do not lose the committed data if you go with this multi-node architecture with the synchronous replication. So this is how it looks like. You can see I have one master and then two standby, right? So the green line shows that the clients are sending read write connections, making read write queries to the master, and the red line again shows that the read only connections to the standby. And then you can see the blue line, which says the first standby is configured in the synchronous mode, and the second standby has been configured in the asynchronous mode. And all the databases are in the different availability zone, right? So to make the node placement quicker. Okay, so these are two, the reference architecture I'll say that you may consider when it comes to designing high availability for your PostgreSQL database environment. All right, so now when we have discussed the inbuilt options to eliminate the single point of failure and the reference architecture, let's talk about the remaining two principles of high availability, which is reliable crossover and the detection of failure, right? So again, I have taken these two definitions from the Wikipedia itself. So as per the second high availability principle, fault tolerant system must provide a reliable crossover for automatic switchover mechanism to avoid the failure. And if these two principles, which we have just talked about, are proactively monitored, then a user may never see a system failure which addresses a third HA principle, right? Which is the detection of failure. But the problem is now, how can you meet this? Regarding the first key principle, which was the eliminating single point of failure, you had inbuilt options available with PostgreSQL in terms of replication methods, right? But what about achieving the reliable crossover, right? What about the detection of failure itself? Because the problem with Postgres replication is that it does not come up with the built-in monitoring, or more specifically, it does not come up with the automatic failover. So when the primary node fails, right, you need to promote a secondary to be the new primary, which of course increases your downtime because of the manual steps involved, right? Also, the promotion which you do manually needs to happen in a way where clients or the application writes to one primary node only, right? It means there should not be a split brain syndrome, right? There should not be two master at a time in the cluster. And of course, your client or the application should not also observe any data inconsistency also. So how will you make sure that all these prerequisites are met by giving this reliable crossover, right? So uh, so the answer is, of course, the EDB failover manager, because this is not inbuilt available with the Postgres. Of course, you will have to rely on either on the error-prone scripts, right, shell scripts, or of course you will need some kind of a tool that can take care of all these requirements. And this is where the EDB comes into the picture. So EDB has a tool called EDB failover manager, which is based on the fault tolerant clustering technology, right? That enables the automatic failover of the Postgres master node to a standby node in case of software or the hardware failure on the master itself, right? What it does, it continuously monitors the system health. It performs periodic health check to the master to see, okay, master is up or live or not. It also performs the periodic check between the standby, okay, whether the standby are doing they are up or not, whether they are in sync or not. So everything it does this continuous monitoring health check. And if it finds something wrong with the master, or if it thinks that, okay, master is not reachable, right, it follows the internal algorithm. And then if all the nodes which are part of the cluster decides that, okay, indeed master is not available, then EFM performs the automatic failover to the most current standby, right? And because EFM works on the VIP, the virtual IP concept, and your application connect to the VIP rather than the physical IP of the server, this failover is transparent to your application, right? And the another important point is avoiding the split brain scenarios. EFM makes sure that in the event of failover, there are only single master available which your client or application can see and can write to. There are no two master at all, right? To avoid this split brain scenario. And of course, if you are using any load balancer on top of the EFM, like PG pool or F5 network, then EFM is tightly integrated with such load balancers, so that even after the failover, EFM can configure these load balancer to show the correct node status, also to show the correct role of the node after the failover. So EFM comes handy when it comes to achieve the second and third high availability principle, which is reliable crossover and detection of failure. Okay, so this is how it looks like. I'll say this is the basic EFM architectural diagram, how EFM is set up or configured. So for primary, you have one primary server and at least one standby and one witness node. Witness node is used to meet the quorum in case of failover. So actually you need, minimum 3 nodes in the EFM cluster. If you do not have more than one standby, then you can use witness node, or better you use one master and two standby for many reasons. So for example, let's say if you have more than one standby, what you can do is you can have another tool on top of EFM, for example, PG pool for the load balancing, right? Or also so that you can use these idly sitting standby for read-only queries, and so that you can achieve the horizontal read scalability. So this is how the basic architecture of the EFM looks like. All right. Okay, so now, whatever we have discussed so far, that mostly covers all the aspect of the database high availability, right? However, oftentimes the organization still needs to provide some disaster recovery capability, in the form of backup to meet some of the RPO or the RTO objective that you might have, right? So to meet your RPO and RTO goals, EDV provides one another tool called BART, or the backup and recovery tool. So let's see what that BART tool is. So BART, I'll say again, is a tool that takes care of your database backups and the recovery challenges. Okay. Uh, it not only helps you to automate your database backups, it also helps you to make the point-in-time recovery and the full recovery easy and automated way. It takes care of archive wall management. It also takes care of backup retention based on the retention period, backup validation, compression, and many more, right? And the best part of the BART is it also provides incremental backup capabilities, right? So the incremental backup capability is missing natively with the Postgres, but BART has this capability of performing the incremental backup. So rather than performing the full backup all the times, right, you use a combination of full and incremental backup that eventually saves, I'll say, the storage cost and time of your DBAs, right? So this is how the architecture look like. So basically, BART can be configured in one of the two ways. There is a traditional command line interface that we provide with BART, right? So if you install BART RPM, you also get a CLI, and then you can use that command line interface, that CLI, to interact with the BART. But BART can also be configured using another tool called Postgres Enterprise Manager, the PEM tool, which I'll talk about in next slide. But the best, when you configure BART using PEM, that provides you a GUI mechanism to configure the BART, and it becomes sometimes more easier than using the CLI. So basically, BART is installed on a dedicated server called BART host. And this is the host where BART catalog resides. And then this BART has a configuration file where you can specify a number of stanzas monitoring your BART host, or monitoring, you can specify the database server which are being monitored by the BART, right? So in short, the BART catalog stores information about all the backups, whether it is full backup, whether it is incremental backup taken by the BART, and along with the archived wall file for each and every BART managed database server. And with this information in mind, BART helps you to perform full recovery and point-in-time recovery, right? So for example, let's say you have a full backup, right? and then subsequent incremental backup. And then you also have a wall archive. So, what BART will do is it will help restore the full backup, restore the appropriate incremental backup, and then apply the archive walls that needs to be applied, and then it gets you to the point where you need to be. I mean, where you are expecting to be from your chosen backup, or where you are expecting to be from your chosen transaction, or the chosen timestamp which you specify during the point in time recovery using the BART CLI. All right, so this is one of the important tool which helps you to manage the business continuity, or to make your backup and the disaster recovery infrastructure robust and solid. Uh, After that, we have one more tool which you can use for high availability monitoring. So high availability monitoring, of course, is another very important part of having a true HA in place, right? There are reports that say that one important thing that causes outages is the lack of monitoring of your system, right? You must need to have some provision in place that can keep an eye on your system, so that you can actually prevent the problems from occurring that might actually cause an outage. And EDB does have a tool to support that requirement. And that tool, as we discussed in the previous slide, is PEM, the Postgres Enterprise Manager, right? So what this tool is all about. So the Postgres Enterprise Manager, it provides a single pane of glass view of your different Postgres databases, and of course the database servers where your database resides, and it also provides the dashboard of that. So basically, it provides over 200 built-in alert template that you can use to notify when there is a problem that need to be addressed, right? It will look at things like memory utilization, CPU utilization, or the available storage and all, right? And what you can do is these alerts can be configured with the different threshold values depending on the requirement. So BART has so many things for your DBAs, for your developer, for your architect, right? Uh, it's not just the monitoring tool. It's a tool with monitoring capabilities. It's a tool with administration capability. It's a tune with the tuning capability, right? So apart from the monitoring stuff, which we just discussed, this tool can also be used to perform certain administration tasks. So for example, creating databases, creating database objects, right? Performing TML, DDL, etc. The PAM can also be used to perform the maintenance task, right? It can be used to update the statistics, right? And the best part of the PEM is, if you have a developer and who are not very much comfortable with Unix prompt, developer can access their database. They have full control on their data in a GUI mode, and they can work on their data rather than connecting to the database using the PSQL prompt utility and then interacting over the Unix prompt. PEM also helps you to tune your PostgreSQL databases, right? PEM has a SQL profiler, index advisor. PEM also has performance diagnostic dashboard, and many more such features that help you, doing the performance diagnostics of your database or the SQL query related issues. So as I said, your DBAs, your developer, and PostgreSQL. PEM is the one-stop shop for them for all their day-to-day needs when it comes to managing and handling the databases, or managing or handling the data, or the database performance related issues. Okay, so this is again a generic architecture of PEM, I'll say. PEM has three important components. One is, of course, the PEM server or the PEM repository database. And then you have PEM agents, and then you have PEM web service or PEM web client. So PEM agents will be installed on all the databases which you want to monitor via PEM. And then these agents which are there on the databases will send the database related and OS related statistics to the PEM server that will be stored in the PEM backend database, PEM repository server, you can say. And then a user can use their choice of latest browser to connect to the PEM server to view and interact with the dashboard, the PEM dashboard and various PEM graphs. Okay, so this is how you can utilize, your EDB PEM tool to monitor your complete high availability infrastructure. All right, now what next? Okay, so this is the last slide of today's presentation. And if you ask me to conclude what we have discussed so far in last 45 minutes, I'll say that we need streaming replication, which is the preferred option nowadays. And then we need EFM, which is a failover manager, to meet the second and third high availability principle, which is reliable crossover and detection of failure. We also need a BART, right, to have a solid, robust business continuity plan in place, right? And then we need a PEM to monitor your complete high availability infrastructure. So if you are really looking for a true high availability, and that too with proper business continuity tools. Also, if you are designing high availability, right, you need to make sure that you are considering your RPO, your RTO, and that too along with the near zero downtime upgrade so that you can achieve your committed service level. Okay, these are a few of the resources which I have referred while creating these slides. You may also want to go through these resources because it contains detailed information, what are the other factors which you may want to consider for high availability, how you can perform zero downtime patching or upgrading of your PostgreSQL instances using the EDB failover manager. You can also look for the plan and strategies for DBAs when handling the failover situations, when handling the near zero downtime upgrades and all. So these are quick resources for you, and I have pasted the link here on the slide for your reference. All right, so Violet, I'm good for question answer if we have any.
Thank you very much, Alok. That's a very interesting session. Yes, there are actually quite a number of questions. I'm deciding which one to ask you. Okay, so first one, what about Patroni? Is it equivalent to EDB Postgres failover manager? If not, what is more on EDB manager? I think what this person is saying is asking about Patroni. How does it compare with EDB failover manager, and what else available on EDB platform? I guess for high availability.
Okay, so Patroni, I apologize. I don't have much information about Patroni at the moment. But yeah, as far as the EFM is concerned, the best part of the EFM is that it takes care of almost everything you really need to take care of when it comes to designing high availability. As we have already discussed this, right? Whether it is monitoring your cluster health, whether it is taking care of your reliable crossover concern, switchover, switchback, or if it comes to detecting the failure, EFM is self-sufficient to to take care of all these requirements. Regarding the Patroni, probably I can do some offline study and then I can give you the comparison between the EFM and Patroni.
Okay, thank you, Alok. One more question. This is with regards to MySQL. This person has asked, in MySQL, we have Galera and group replication for clustering, multi-writes as well as we can write on any nodes and read as well. Do we have anything like that on EDB Postgres?
All right. Yeah. So if I have understood this question correctly, the question is about write capability. So rather than having one primary and other standbys where you can send write only to primary and not to standby. Yes, so with EDB, we have tools which you can use for achieving the write scalability. We have a tool called EDB replication server, right, which has the multi-master capability, which you can utilize. And on top of that, as I just said, that the EDB has, acquired the second quadrant. So now there is another tool in our portfolio called BDR. So BDR is bidirectional application, which can be used to have multi-master capability for your high availability environment. Yes, so of course, in short, we do have these options.
Okay, thank you, Alok. Another question is, in synchronous replication, consider a primary and a standby. In case my only standby went down, will it affect my primary anyway?
Yeah, so if you are configuring the synchronous replication, of course, and if you have only one standby, yes, because your standby is down, and single standby is down, you will face a kind of hung situation where your master will not accept the further write because it has been configured in a manner using that synchronous standby name parameter. So the best option is then you have what you can do is either you can have more than one synchronous standby, or let's say if you want to avoid that performance hit having two synchronous standby, what you can do is you can have one synchronous standby and then you can have an other standby as a potential sync, so that if something goes wrong and your first standby goes down, your second potential sync can become the synchronous standby and your transaction can continue. Your primary can still, can accept the write, and your application will work as it is. You will not face any problem.
Thank you, Alok. Just one more question. This person is asking, is Postgres for free? I think maybe what he wants to know is all that you have explained or presented, is it available on the standard Postgres, or is it only available on EDB Postgres?
No, of course, we do have, we have the different, I'll say, licensing scheme, I'll say, but yes, we do have a standard version of Postgres where you use the community PostgreSQL. And on top of that, you use all the EDB tools. So all of our EDB tool works as it is with community PostgreSQL as they work with enterprise EDB Postgres. So you could use free Postgres available with community, and then on top of that, using our standard subscription, you can use all of our tool, including EFM, which I have talked about, using the BART, using the PIM, and can have a truly high available database environment.
Thank you, Alok. One more question. Okay, this person asks, how can we achieve multi-master replication?
Okay, so the answer is same, I believe, as I just answered. We have using, of course, I mean, using the options which you have discussed, you can't achieve that. But of course, EDB has tools in its portfolio. We have a tool called XDB, or EDB replication server, which can be used to achieve the multi-master replication, right? And then we have a tool called BDR, bidirectional replication, that can also be used to achieve write scalability, or for having multi-masters in your high availability setup.
Thank you, Alok. One more question. This person asks, please share some insights on EFM on AWS RDS workloads.
Yeah, interesting questions. So EFM can be used on any platform. That's the beauty of EFM, right? If you are on virtualized environment, if you are using bare metal, or if you are using if you are a cloud user, whether it is a public cloud, AWS, Azure, or Google Cloud, you can use EFM everywhere. right? So the same failover or the switchback functionality, which you can use on premise or on virtualized environment. The same kind of functionality can be achieved being on the cloud platform. So you can have your databases in multi AZ environment. You can have databases in multiple availability zone, and EFM is capable to detect the failure and then perform the failover across AZ using its inbuilt technology or the algorithm inside the EFM. So yeah, in short, EFM can be used for on-premise environment platform. It can also be used for the cloud users.
Thank you, Alok. I think we only have time for one last question. And this person actually asks to explain about the cost of BUTs and PEM tools. So I think we can follow up with him after the call. But he wants to know whether EDB also provides support as well along with the tools, or do we just sell the tools?
No, of course. Yeah, so when it comes to PostgreSQL, EDB is preferred choice. We, as I said, we provide software and services, of course, along with the 24/7 support, right? So you have tools which you can use. On top of that, we provide 24/7 support. So we have a team of PostgreSQL experts, contributors who are there to take care of, your databases if you're running business critical applications. And then, of course, we have a professional services team where we have PostgreSQL experts with a decade of experience, who are very much well versed with when it comes to migrating from your legacy database to EDB Postgres, or if you are new to the Postgres journey and you need help in terms of quick deployment of Postgres, creating a quick PostgreSQL setup for them. Or let's say if you are looking for other services like performance tuning, backup and recovery best practices, architectural services, or architectural health check service and all, we have a professional services team, and they are ready to help you whenever you are in need, wherever you are in your PostgreSQL journey.
Thank you, Alok, and thank you everyone for attending. We have come to the end of our session. We are only like 2 minutes left to the top of the hour. So I just want to thank everyone for attending, and please remember that we will share the slide deck and the recording with you. I suppose somebody asked whether they can watch the recording offline. I guess you can download it when you receive it, so you can watch offline. So before we close, I just want to remind everyone that we do have another APJ live webinar on December 3rd, which is a Thursday, and the topic is Understand the Query Plan to Optimize Performance with Explain and Explain Analyze. So I really hope to see all of you at that webinar too. And once again, thank you, Alok, for the wonderful session, and thank you all of you for attending. Have a great day. We will send the recording and slides to you soon. Thank you very much. Bye.
Thanks, everyone. Bye-bye.
Bye.